Okay, we're going to start instruction off with some earth science basics. These are some things that come up again and again throughout the curriculum. These are things that you're going to hear about over and over again, and information that you're going to need to have and use over and over again. So I like to start off with this information and go ahead and, without going too far in depth, just go ahead and get the basic information out in the open so you can begin to use it from the very start of the course. Alright, the first thing we're starting with is resource basics. Of course, us humans and all other living things require different sets of resources in order to survive. And the thing about that is that the Earth only has a certain amount of resources to give us in the first place. So we have to use these resources responsibly. We're reaching a time in human history where our population has grown so large that it's possible to use up certain resources. So the Earth has a limited amount of resources. You'll hear that again and again. Sometimes you'll see the word finite used. Finite means limited. They can run out. They won't last forever. Alright, some resources are renewable. You've probably heard of renewable and non-renewable resources before. Some resources are renewable, meaning they can be replenished, or you can make more of them, or more of them will come about naturally, again, in a reasonable amount of time. We're talking about things like the crops we grow. Trees are actually a renewable resource if used sustainably. Energy that is created from sunlight, wind power, so on and so forth, wave power. Okay, so some of these resources we can get more of. They'll replenish themselves, or we can replenish them in a reasonable amount of time. Other resources are non-renewable. Right? They cannot be replenished in a reasonable amount of time, and it is possible for us to use them up if we don't use them in a sustainable fashion. If we use them too quickly, we can use it all up. The number one example of a non-renewable resource that we'll be talking about in this class is any type of fossil fuel. We're talking about oil, natural gas, coal. These are fuels, these are substances that took millions of years to form. So for more of them to form, it's going to take millions of more years. And thereby, we can use those up before they could ever be replenished again. So we consider those resources to be non-renewable. Now, some resources we consider to be renewable could be rendered non-renewable if we use too many of them too quickly as well. But I'm not going to go so far into depth on that just yet. Now, all of our methods for obtaining these resources that we need have some kind of environmental impact, and unfortunately, it's almost always a negative impact. So when we farm for our food, when we harvest peat and other materials for energy, when we mine for the materials that we need to make the goods we use, we're having some kind of environmental impact. There's always going to be some kind of environmental impact, and therefore we have to make sure that our methods for obtaining those resources are sustainable. They're methods that we can use again and again without doing too much damage to our environment. It's a way that we can keep the environment healthy. We can keep obtaining resources on and on into the future. So, like I'm saying here, in order to continue to survive, we must move toward the use of renewable resources, away from the use of non-renewable resources, and we have to make sure that those renewable resources are being obtained and used in a manner that can continue to be used on and on into the future. We're not going to be using them in a way that we're going to run out of the resources, or we're going to ruin the parts of nature that provide those resources. That's what we mean by sustainable. Sustainable is something we can continue to do on and on into the future without causing considerable harm or damage. All right, another topic, global warming basics. We're going to hear a lot about global warming and climate change throughout the semester. Humans and animals breathe oxygen in. We use the oxygen in a process called cellular respiration that allows us to use the energy from our food. And during that process, oxygen and other materials are converted into carbon dioxide, which we exhale. And we have a relationship with the trees and other plants because they need the opposite of what we need. We need the oxygen from the atmosphere, and then we exhale the carbon dioxide as a waste product. Meanwhile, the trees and the other plants, they need to absorb carbon dioxide for their processes that they use to survive, and they convert carbon dioxide and other chemicals into oxygen, which they release back into the atmosphere for us to use again. So we have this kind of cyclic activity going on here where we breathe in oxygen, exhale carbon dioxide, the trees absorb carbon dioxide and release oxygen. So we have kind of a mutual relationship with the trees and the plants. The more trees we have, the less atmospheric carbon dioxide we will have, and the more atmospheric oxygen we will have. In other words, the more trees we have, the less carbon dioxide we'll have in the atmosphere and the more oxygen we'll have. And we want to have a certain amount of carbon dioxide. We don't want too much, but we don't want too little. And we need enough oxygen for us to use and survive off of. All right, the less trees we have, the more atmospheric carbon dioxide we're going to have and the less atmospheric oxygen we're going to have, which is not a good thing because carbon dioxide is a greenhouse gas, meaning it has this special property. It's very good at absorbing heat energy, and it also can emit it back at the Earth's surface. So really, carbon dioxide is talked about a lot like it's the bad guy because we definitely don't want too much of it. Okay, if we get too much carbon dioxide in our atmosphere, we suffer global warming and associated problems such as an increase in the occurrence of hurricanes and other tropical storms, crop failures, droughts, melting glaciers, among other problems. So we don't want too much carbon dioxide in the atmosphere, but we do need enough of it. If we did not have enough carbon dioxide in the atmosphere, the Earth would be too cold to support life. Okay, so it's going to sound like over the course of the semester we're beating up on carbon dioxide a lot, but it's actually something that we do need the right amount of in order to survive on planet Earth. All right, moving on to density. Density is a subject that comes up again and again and again. It's in almost every unit across this curriculum. The simple definition of density is that density is the amount of material in a given volume. Here in this picture I have a foam ball, which is kind of like you might play with in a PE class. Okay, one of those really lightweight foam balls. You can throw it at each other's head and it's not going to hurt. And then on the right we have a bowling ball, which everybody knows what a bowling ball is like. And it's very heavy. Okay, so these two balls have the same volume. They're the same size. They're taking up the same amount of space. Okay, they have the same volume. But they do not have the same amount of material in them. The foam ball has much less material in it than the bowling ball does. The foam ball has very little material. In fact, there's all these kind of empty spaces in the foam ball where air exists, right? On the other hand, the bowling ball is very solid. There's a lot of material packed into that volume. Therefore, the bowling ball is much more dense than the foam ball is. Okay, again, they're both the same size. Okay, they both have the same volume. They're taking up the same amount of space. But the bowling ball is much more dense because there's much more material packed into that given space, that given volume. Okay, now the density of materials can change under certain circumstances. For example, you've probably learned in science class in years past that if you have a material and you heat it up, it will expand. On the other hand, you could take the same material, you could cool it down, and it will contract. It'll get a little bit smaller. Okay, so these are the general rules here. All right, heated material expands. Okay, when it expands, its volume increases. Okay, even if it's only a slight increase, but when a material expands, its volume increases. You still have the same amount of material, but the volume has increased. So what happens is that object or that material becomes less dense. Okay, you could imagine if we had a steel ball, we put it under a flame and it expanded. Okay, let's go ahead and say that nothing happens to any of that material. None of it goes anywhere. Okay, but that material expands. It has a bigger volume, but still has the same amount of material packed into it, so it is now less dense. On the other hand, if we had the same steel ball and we put it on ice, it would contract some. It would get a little smaller. Its volume would decrease. It would still contain the same amount of material though, so it would actually at that point be more dense. Okay, this might seem a little bit confusing, but for instance, we can think about water. Okay, when water is heated up, it expands a little bit, it becomes less dense. When it's cooled, it contracts, it becomes more dense. All right, in a given material, let's say we have a lake and it's full of water. The warmer water is going to be less dense, and in that lake it's going to rise. At the same time, water that is cooler is going to be more dense and is going to sink down towards the bottom of the lake. And this continues to happen in a cycle. So warmer, less material is going to rise, cooler, more dense material is going to sink. And this applies to any substance, okay? And why this applies to any substance, the main substances we're going to talk about in class are going to be water, air, and magma. So these density basics that I've just shown you here, they're going to apply to water, air, and magma. And that's going to be the materials we talk about the most in our science class. Now, when we're talking density and we're talking warm versus cold, in some instances, warm or cold would be obvious. One material might feel hot, the other one might feel really cool. But that doesn't mean you have to have material that is, has that much contrast between the two. You can have material where all of it's hot, very, very hot, but some of it is not quite as hot as other areas. So we would use those relative terms, warmer and cooler. Maybe none of it is technically warm or none of it is technically cool, but some parts of it are warmer or cooler. For example, here in this picture, we have a cross section of the earth and we can see the magma inside the earth. Okay, I'll try to use my mouse pointer here. All right, you have hotter material rising up. It's less dense, it's hotter and less dense. Magma is rising up towards the surface. All right, it begins to cool off, and as it cools, it gets more dense. Okay, its volume decreases and it gets more dense and it begins to sink again. Okay, and this continues to happen in these little cycles. We call them convection cells. Okay, so none of this material inside the earth is cold by any means. It's all hot. We're talking melted rock here. But some parts of it are hotter and they're thereby less dense, so they're going to rise. And other parts of it are cooler and more dense, so they're going to sink.